we have this function x square minus 3x plus 2 by x cube minus 4x. We have to find the limit of this function when x tends to 2 plus or minus 2 plus 1 plus and 0 minus. Okay, so this is a rational function, right? This is a ratio of two polynomials. The first polynomial, the polynomial in the numerator is of degree 2 and the denominator is of degree 3. Let us try to find if there are any common factors. Numerator we can write it as x minus 2 into x minus 1, right? X square minus 3x plus 2, right? This becomes x square minus 2x minus x plus 2, which is this one. Denominator we can write it as x into x square minus 4, which is nothing but x square minus 4 we can write it as x minus 2 into x plus 2, right? So we can cancel this x minus 2 in both the places as long as x is not equal to 2, right? So this is equal to, as long as x is not equal to 2, we can cancel this. Basically, this function, this entire function is identical to this function as long as x is not equal to 2. At x equal to 2, this function is defined, but this is not defined. Okay, so now let's take care of this function. We have what? We have x minus 1 into x plus 2. Okay, if we take the number line, we have 1, x minus 1, x equal to 1, and x equal to 0. This is 0, this is 1, and somewhere this is minus 2, x plus 2, right? Now we have these three important points, 0, 1 and minus 2, right? So when at 1 the numerator is 0, so at this point it will be 0. Okay, at will point it will be 0, and at denominator at x and x plus 2, that is x equal to minus 2, there will be vertical asymptotes because the denominator will become 0, right? At these 2 points there will be vertical asymptotes. Right. Now, at the same time, we have beyond 1, this is positive, this is negative, this is positive, this is negative. Right. We know for a polynomial or a rational function, when it is factorized into multiple factors, we know how to put the signs. Right. We'll put it in the ascending order. And here there are no even powers. So that's why we can say this is plus here. X greater than 1 is positive because everything will be positive. Between 0 and 1, this is negative, and these two are positive. Likewise. Okay, we can say like this. Now, what does that mean? When x tends to 2 plus, x tends to 2 plus somewhere here. Okay, somewhere here. So we can directly substitute because here we are not worried about anything is 0 in the denominator. 0 in the denominator is only in these two cases. When x tends to 2 plus, we will directly substitute. That is a 2 minus 1 by 2 minus 1 by 2 into 2 plus 2. That is 1 by 2 fourths, which is equal to 8. Right. This limit is equal to 1 by 8. See, this function is not defined at x equal to 2. Right. Because there is a denominator in this function, x minus 2. This function is not defined, but this limit at x equals to 2, when x tends to 2 plus, is 1 by 8. That means we can make this function as close to 1 by 8 as possible. Basically, when x equal to 2, there's a hole here. There's a hole here. Okay, that hole, the value of that hole is 1 by 8. If you want to fill this function, we can put that. Okay, by the way, this is the graph of this function. Now, that is 2 plus. 2 plus the graph. So 2 plus is defined, this function is defined, and we can directly substitute, and the value of that will become the limit here. Okay, x tends to minus 2 minus. Minus 2 is this. Minus 2 minus means we are approaching from the left hand side. Okay, we are approaching from the left hand side, and less than minus 2, it's always negative, and there is an asymptote here, so it should be minus infinity. So it is minus infinity. Okay, so you can see it here. When you are approaching from the left hand side, this graph, it is approaching minus infinity. Similarly, 0 minus. 0 minus means you are approaching 0 from the left hand side. Again, it should be 0 minus should be positive, right? Because this is in this range, right? It is in positive. So this should be plus infinity, right? And x tends to 1 plus. 1 plus is actually 0, right? 1 is the numerator. So this is equal to 0, right? This is a factor. 1 is a factor of the numerator. So this is equal to 0, right, guys? Sorry, please note here it is minus 2 minus. Minus 2 minus is minus infinity. Here minus 2 plus is given. right? Minus 2 plus means we are approaching from the right hand side. So this should be plus infinity, right? Because this is the graph is going upwards. Minus 2 plus means we are approaching from the right hand side. Right hand side it is positive. All this area is positive area. If we are approaching from the negative minus to minus, when x approaches from minus to minus, then it is minus infinity. Sorry, my bad. Here it is given minus 2 plus. So this should be plus infinity. Right, yes. Now another important thing, this one, in this rational function is what? Ratio of two polynomials, right? The highest power of the numerator is lesser than the highest power of the denominator, right? This is 3 is greater than 2. What does that mean? This function will have a horizontal asymptote at which is the x-axis, right? Any function like this where the denominator is highest power of denominator is higher than the highest power of the numerator, when this function is a rational function, that is the ratio of two polynomials. What does that mean? X-axis is a horizontal asymptote, right? So you can see this here, right? The graph is approaching x-axis, approaching as it tends to minus infinity or plus infinity. This function will approach 0. It is very easy to verify this also, right? If we divide everything by x cube, right? If we divide everything by x cube, in the numerator will be 1 by x minus 3 by x square plus 2 by x cube. In the denominator, what will you get? 1 minus 4 by x square. So this everything will tend to 0. Right? Basically, what will you get? 0 by 1, which is anyway 0. Right? This is very easy to verify also. Basically, what we are trying to say, in any rational function, when the denominator, the highest power, is greater than the highest power of the denominator is greater than the highest power of the numerator, then x-axis is a horizontal asymptote. Right, guys? Thank you.